This lesson is on synthetic division. So in a previous lesson, we did long division. Now we're going to look at another way to divide without using long division. So go ahead and pause the video and read this first page, this example and the steps that were taken, and then let's try some practice together. So what you should have noticed in this example is it is exactly like the example that we did with long division, and we got exactly the same answer. So totally different process, similar but different, and we got the same answer. So that's a good thing. So let's go ahead and practice. Let's look at exercise 2. So in this question, the directions are to divide each of the following. That's nice because we could use long division on these. You can use long division or synthetic division as long as your factors or your dividers, they're not always factors, so what you're dividing by does not have a coefficient in front of x. So if this said 3x minus 2, I could not use synthetic division, okay? So your roots have to be whole numbers, or your factors cannot have coefficients in front of x for synthetic division. For long division, you can do anything you want, just like we did in our examples. So the first thing that we do is we take this factor and we find the root, and that's what we write on the outside. So 2 goes on the outside. Now we have to list the coefficients, and again, we have to list all of them because we need space holders if there aren't any. So this starts at the 4th, and we have to go down to none, which we do. So the coefficient of x to the 4th is a 1. The coefficient of x to the 3rd is 1. Then negative 11, then negative 5, and then 30. Hopefully that's good. Leave a space, draw your line, because that's where our work is going to go. We always bring down the first one. Now we are going to multiply. So we have to multiply 2 times 1. So 2 times 1, and that answer goes here, and that's a 2. Then I want to add these together, so I got 3. So now I'm going to multiply that one by 2 and get 6. Then I'm going to add these together and I get negative 5, and then I'm going to multiply that by 2 and I get negative 10. And then add those together and get negative 15, and then I'm going to multiply those two together and get negative 30, and I'm going to add these and I get 0. So what the heck do these numbers mean? Well, since I started with x to the 4th and I'm dividing by x, I know that this is x3 term, and this one is x2, and this is x, and that's my constant. This is my remainder. So what is your answer when you divide that polynomial by x minus 2? You get x to the 3rd plus 3x squared minus 5x minus 15. You could also say that x minus 2 is a factor of that polynomial. You could also say that 2 is a root. All right, if you're good to go, then pause the video and do the next one. If you're not good to go, then keep listening. We'll do this one together. So if I know the factor is x minus 1, I know the root is 1, so that's what goes on the outside. My coefficients, well, there's a lot missing here. So x to the 3rd is my highest exponent, so that coefficient is a 1. Now I have x squared, that's a 0. Then I have x, that's a 0. And then I have the constant, which is negative 1. So be very careful. We know it's ax to the 3rd plus bx squared plus cx plus d. So you have to have 4 terms in a cubic, okay? Where we had 5 terms in a quartic. So 1 higher is how many terms you have because of that constant, all right? So then we're going to draw our line, leave a space. So we always bring that first one down. We're bringing down the 1. We're multiplying what we bring down by that number out front. So 1 times 1 is 1. Add these together, you get 1. So 1 times 1 is 1. add these together. 1 times 1 is 1. Add these together. Because I started with x to the third and I divided by x, I know that this is x squared. This is x, this is my constant, and this is my remainder. So my answer is x squared plus x plus 1. So again, both of those do not have remainders. Does that always happen? No, of course not. So we got lucky on those two. So I can say that 1 is a solution or a root, and I can say x minus 1 is a factor of x cubed minus 1, which, hint, hint, I should already know how to do, or I should know that answer, because x cubed minus 1 is a perfect cubes. I could factor that if I wanted to. All right. Haha, I don't. All right, let's look at the next example. In exercise 3, we have been given a division, and we, in part A, are asked to perform synthetic division. So, let's go to it. How about this? You try this one on your own. Start the video when you're ready. All right, hope that one was really easy. So just like the beginning of the last lesson, equivalent multiplication, so this is the way you can check yourself. So our answer was 2x plus 3. If we multiply it by what we divided by, x plus 6, it better equal 2x squared plus 15x plus 18. Okay? All right, in part C, it says to write this division in the form of q of x plus r over x plus 6. Well, isn't x plus 6 what we're dividing by? So they're just telling us to do the division. That would be q of x, and then your remainder goes over x plus 6, which is what we did when we long divided in the last one. So we are using synthetic division. So my factor is x plus 6, so my root must be negative 6. It's a polynomial, so 2, 15, and 20. Bring down the 2. Negative 6 times 2 is negative 12. Add them, I get 3. Negative 6 times 3 is negative 18. Subtract them, I get 2. Because it was x squared divided by x, this is my x, this is my constant, this is my remainder. So my answer is 2x plus 3, that's the q of x part, plus my remainder 2 over what I divided by, x plus 6. Okay? It tells me to also write it as an equivalent multiplication problem. So if I take my answer, 2x plus 3 plus 2 over x plus 6, and I multiply it by what I divided by, it should equal what's on top, 2x squared plus 15x plus 20. And maybe if you don't, you don't see how that happens, ask me in class and let's do it together. Okay? So when we divide two polynomials, we always get another polynomial and a remainder. This is known as writing the rational expression in quotient remainder form. Okay? So go ahead, pause the video, and read this division algorithm. So we're going to do a couple examples just so you can start to see what the heck all those letters mean. Okay? All right, so we'll notice that these denominators do not have coefficients in front of x, so I can use synthetic division. So if my factor is negative 3, or x minus 3, my root is 3. My coefficients are 1, 2, and negative 5. Bring down the 1, multiply, add them together, multiply, add them together. Because I divided x squared by x, this is my x, this is my constant, this is my remainder. So my answer is x plus 5 plus 10 over my divisor, which is x minus 3. Now if we're looking at our division algorithm, this part right here, I guess I should use a different color. This part right here is your q of x. This part right here is your r of x, and this is your d of x. Okay? Hopefully that makes some sense, all right? If you're looking at how it told us to write it, q of x, this is q of x, plus, this is your r value, so r equals 10, x minus a, so a equals 3. I don't know. And again, you guys, they could ask you a bazillion different questions. They could ask you to write your answer in this form and just say, what is r? All right? So that's why you've got to be able to take your answer and then go back and put it in that form, whatever they're asking. Can you pause the video and do letter B by yourself? And then continue to ask or to check your work. All right, how did you do? Hopefully you did okay. I put parentheses around the 2x minus 3. You don't have to. You can leave it with or without. All right, so it says sometimes we can use the structure of an expression instead of synthetic division. So these, make sure if you need to take a break, stand up, stretch, and then come back to this, because this can be rather confusing. So instead of actually dividing, we're just going to rewrite things, okay? Excuse me. All right, so consider the expression x plus 8 divided by x plus 3. You would like to write it as a plus b divided by 3, but we're not going to use synthetic division. So we're going to rewrite this as, rewrite the numerator as an equivalent expression. So equivalent in an expression is not an equation, involving x plus 3. So how can I make this numerator, x plus 8, into x plus 3 plus something else? Because I want to make it equivalent. So I'm going to take x plus 3, and I'm going to add to it 5, correct? And that gives me x plus 8. And I'm still going to divide by x plus 3. All right? Now it says use the fact that division distributes over addition to write the final answer. So what that means is, on the top I have technically 3 terms, but I can group the first 2. So I can take x plus 3 plus 5. Now I'm going to divide the first set by x plus 3, and I'm going to divide the second one by x plus 3. Alright, that's what that means. Division distributes over addition. So what is x plus 3 divided by x plus 3? 1 plus 5 over x plus 3. So if I had to use long division or whatever, this is the answer I would have gotten. So it's easier to rewrite it sometimes than to actually do the long division or synthetic division. Okay? If I want to check myself, remember, your answer times your divider has to give you the numerator. So this is your check. Can you see it? All right. So you distribute, and you would get x plus 3 plus 5, and that equals x plus 8. All right. And if you need help with that check, please make sure you ask. All right, let's try a couple more difficult on the next page, and then we're done. All right, so this one, we need to have x plus 2 as our divider. So if I have x plus 2, I'm going to add to it 3x plus 11. But can I take another x plus 2 out of 3x plus 11? Okay, so think about 3x plus 11 is left. So can I take another plus x plus 2 out? Then I would have 2x plus 9 plus, I can take out another one, so x plus 2, which is another x plus 7. So I can take out another x plus 2, and I get 5 left, right? So I'm just keep decreasing the numerator by x plus 2. Well, think about these things. Couldn't I have just taken out 4x plus 8? Plus 5 divided by x plus 2? Some of you, I probably just blew your minds. All right, but I just kept taking out x plus 2's from the numerator because that's what divides in evenly. So now I know that 4x plus 8 divided by x plus 2 plus 5 over x plus 2 is 4 plus 5 over x plus 2. Whew. Hope you're okay with that. If not, make sure you ask. Let's try this next one. Alright, so we're dividing by x minus 4. So how many x minus 4's can we take out of the numerator? Well, we can take out 1, x minus 4. If we take that out, we have 2x minus 1 left. Well, we can't take out any more x minus 4's, can we? So we're going to say plus 2x minus 1. And then we're going to divide by x minus 4. So we know when those divide, we have 1 plus 2x minus 1 over x minus 4. I'm thinking that you could keep taking out x minus 4's. So if I took out 1x minus 4, I have 2x minus 1 left. If I take out another x minus 4, I have x plus 3. And if I take out another x minus 4, that means I have 7. All that is divided by x minus 4. So I really could have taken out 3x minus 12 plus 7 divided by x minus 4. So this would be 3 plus 7 over x minus 4. So which one do I like better? I definitely like the second one better because I just have that single coefficient remainder. So cross off that first one and say no and keep that second one. So you want to keep dividing till you just have a constant for your remainder. It's a little difficult. I could see them giving this to you in a multiple choice or in a very weird way. Maybe saying prove this equals this. If you have any questions, please don't hesitate to ask in class tomorrow. Good luck!